All right, back on the SuperCube III. The customer did approve the estimate, so I do have replacement parts in stock. And it might be kind of hard to see, but I did take a knife and slice this glue they use, especially around that little capacitor right down there, that surface mount cap. And so hopefully this will come out peacefully. I did go ahead and slice around the LED as well. Hopefully it will release peacefully. So all that's left to do is pull the screws out of the board. You can see a couple screws right down there. And then there's a screw there and another screw right down there. I've got to remove the screws out of the jacks here. Take the nuts off. Those are the two screws you saw. Take that nut off. And then very, very carefully coerce this board off of the aluminum plate. So let's see if that's going to work in my favor. Hopefully, yes. Hopefully that cap's not going to give me problems on it. That is the only thing that I'm worried about. Okay, well, the board did cooperate. No damage to the little surface mount cap right there. And so the LED came out peacefully. Everything's good. We have an amicable divorce. All I need to do is remove the hot and the neutral leads from the power supply, feeding the standby right here. And then I think we can just go ahead and replace these three pots and everything is going to be good to go. Once again, very happy with this outcome. So when I go ahead and put this thing back together, I will go ahead after reassembly add a bead of RTV silicone around this just to seal this for air tightness. That's why they did it. Now I'll just put a blob of RTV around that as well. Seal that LED so it doesn't move whatsoever. And I think everything is going to be good on this thing. Well, I was mistaken, and I will be the first one to admit my mistakes. I thought this pot was a 1K linear taper pot, and I was mistaken. It is an audio 50K pot. So I do have a corresponding audio 50K pot right there. This one is correct. A linear taper 20K pot. And then I was correct on this one. It is an audio taper 5K pot. So because this one is a audio taper 50K and I only have a stereo pot, we're just going to use one section of it. We won't use both sides of the pot. So basically we'll just use either the three inner or the three outer leads and just disregard the other three. They'll be perfectly fine. Now this one that I found is an exact drop-in replacement. I do believe I need to cut the shaft off slightly because if you look at the difference in the shaft length, you'll see this one, if I line it up with the flat part on that one, does have a longer shaft, so I will have to take a little Dremel type tool and cut the shaft off of that one, which I did on the last one. Worked perfectly fine. And then this one is the other audio 5K pot, and I think the shaft goes up into the knob far enough on this one where I did not have to cut the shaft off, but you can see the difference in shaft length on that one is probably about 1/4 inch longer, so I will have to cut the shaft off of that one. Now this one, unfortunately, is actually a little bit shorter than the original shaft. There's pretty much lined up with the surface right there, but it fits perfectly on the existing knob, so we won't have any problems with that at all. So let's get these things changed out, get this thing fired up and shipped back to my customer. Okay, so just like in the last SuperCube III video, I did go ahead and drill a couple of reliefs on the bottom of these so that these little tabs, you can just barely see the tab right there, mounts in here to keep these things from spinning. I don't have them tight yet, but you can see I went ahead and drilled those reliefs in there just to keep them secure, because these are going to be mounted just with wires to the circuit board. Now this one's going to be mounted to the actual board, so I don't actually have to secure it to the aluminum heatsink. So I did have to go ahead and actually trim off the little tab they had on this one because it won't fit otherwise. So they're just going to go in there like that. Like I said, these two will have leads that attach to the circuit board, which mounts right here. This one will be mounted to the circuit board. So I'm going to go ahead and prep the leads and get these ready to go, and we'll put this thing back together. Okay, so the new pots are installed. They're just kind of hanging here, as you can see. Did go ahead and heat shrink all the leads to the pots. Remember on this one, and it is, let's see, it is the Audio 50K. We only use 1/2 because I could not source a mono pot, so I had to source a stereo pot. And I did go ahead and twist the leads to minimize interference. And so they're mounted, ready to go. Just got to go ahead and mount them up to the heat sink. Now on the 20K, I only soldered one of the leads on it, because once I get the plate mounted at the back of this and secured, I'll go ahead and reflow that single lead to make sure there's no stress on the pot whatsoever, and then resolder the other 5 leads. So I think it's time to go ahead and reassemble this unit and give it a test. Okay, all the new pots are installed. Did go ahead and trim the shafts a little bit, so they're all approximately the same length, and I did go ahead and chamfer the ends just a little bit, just to make it easier to install the knobs on the pots. I still need to go ahead and add solder to that center pot, the variable low pass crossover pot. So let's go ahead and see if the cord will allow me to do it. Okay, all good. Now for a little magical solution, acetone. Clean that flux off the board, and then it's ready for some silicone and then reassembly. All right, well, certainly looks much, much better. Let's go ahead and add that RTV and put this thing back together. So there it is, all back together, siliconed up, ready to go. I personally believe that silicone RTV is a much, much better choice than this glue that can become conductive over time. So back in the 80s, when I just started repairing TVs, I actually put a big blob of silicone RTV on a horizontal output tube that runs very, very hot, probably in the 250, 300 degree range, and one of my own TVs, vacuum tube TVs, and tested it a couple of years later when I had to replace that output tube, and it was still pliable. It had not changed in color whatsoever, and even the tube on this one says that it's good for between 60 and 400 degrees, and it never becomes conductive. So I don't know why these companies didn't use RTV. They use this stupid glue that can become conductive, especially that yellow stuff over there. When that stuff gets hot, it actually becomes carbonized and it begins to conduct electricity. Very, very bad. But enough about that. let's go ahead and put this thing together and give it a test now. And yes, off camera, I did go ahead and add the power supply leads back and remove the old glue that they had on there and added fresh RTV to keep those from fatiguing. And because I've had problems with these caps in the past, that one right there labeled C23 and that one labeled C44. So here are the old caps right here. Let's go ahead and test them with the ESR meter. Powering on, zeroing out the leads, 0.0. So that one reads 3.9. And 2.9. They are 100 microfarad 10 volt caps. Here's a brand new one. 0.18. If I can get my leads to stay on there. And 0.17. Much better. Let's test these old ones again just to make sure. 3.94 ohms, definitely bad. And 2.8, yes. Let's put new caps in this unit. In circuit, 0.17 and 0.16, 0.17. Perfectly happy with that. Much better than 4 ohms on a 100 microfarad cap. Okay, let's hook this up, make sounds, and ship it back to my customer. Okay, here we go, powering on. And as in the last video, remember we have to wait at least 30 seconds before we put audio into this thing. Volume is down all the way. I think it was actually like 35 seconds. Okay, it did power on. Let's crank up the volume. I have it connected to my dummy load right now. And I do hear audio. Volume's working perfectly. Phase alignment, I really have no way of testing that, but I have to assume it's working. Nothing but bass. Higher frequencies, yes. So I'm going to go and turn the MP3 player up all the way. Turn this down a little bit. Okay, there's max volume. There is the point of distortion. You can actually see the lights dimming on the bass. Man, this thing is a powerhouse. Definitely a powerhouse. These things have so much audio. I'm not sure what the RMS output is, but I would bet it's easily in the 300 to 600 watt range. Easily. Anyhow, it's up and running in the dummy load, working absolutely perfectly. Low pass working great. Like I said, I have no way of testing the phase angle here, but this thing is definitely drawing some power, peaking at over 4 amps of AC input power. Slamming the needle over here. But that's it. Another repair on the Definitive Technology SuperCube III. I certainly hope you enjoyed the repair of replacing the pots and a couple of capacitors in the power supply down here just to be safe. Don't want to come back on this thing. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, if you made it this far, I think you like this video. I would appreciate it if you hit that like button and subscribe to my channel. It really helps my channel grow. You can follow me on social media, Facebook, Instagram, Twitter, at NorCal715. You can email me norcal715videos@gmail.com. That is the best way to contact me. Please be patient. I do have a full-time job and I do these repairs in my spare time. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. I really do appreciate it. Stand by for bonus material testing the old pots out of circuit. Everyone have a great day. Once again, thank you so much for watching. Bye-bye. Okay, bonus material testing the old pots. So I have my 117 in the meg ohm range, and just show you how sensitive this is, if I just touch the leads to my fingers, I read 20 mega ohms, 42 mega ohms. So that is 42 million ohms just by simply touching the leads. That's 4 megs. 32 megs, 28 megs. So this is a 20K pot, 20,000 ohms. So end to end, I read 105K. Well, it says 20K. So that's 5 times over what it should read. So let's turn this down all the way. I should get 0, and I get 69K. Yes, that was down all the way. So up all the way, I should read 20K here. And I get 107K. So I should get 0 here. And I read 88K. That's almost 5 times the value of the pot. So on to the other set of leads, which is going to be hard to show because it's an odd position. So it's up all the way. So right here I should get 0. And I read 71K. This one should be 20K. And it's dancing around in the meg ohm range. This one should be 20K from end to end. And I read 81K. Well, that one is toast. So this one is the 50K pot. So I'm going to turn it down all the way. So effectively this lead and this lead should be shorted because this is the wiper. So see if I can hold this still. And it's open. So end to end, absolutely open. Let's just actually test on the pins. Open. Open. So up all the way. Open. Open every way. This thing is really toast. This one, the 20K pot, might have survived, might have passed a little bit of audio. This one is the 5K pot. So once again, down all the way. And I should get 0 ohms between these two leads. And it's open. I should get 5K here. And then wide open, I should get 0 ohms between these two leads. And I'm getting 38 meg ohms, 38 million ohms. I should be getting 5,000 ohms. Now on to the back side, which is harder to show, unfortunately. Open, open, open. Turn it down all the way, so I should effectively have 0 ohms on these two leads. Open, and I should have 5,000 ohms on these leads right here. If I touch the leads together, I get 0.2 ohms. So yeah, toast, toast, toast. Because I know someone's going to ask, let's go ahead and put this in the diode range, and we'll hit the capacitor test button. This will actually test the value of this capacitor right here. And it reads 111 microfarads, 110 microfarads. That's pretty good for a 100 microfarad cap. (109 microfarads). Let's get the MK168 and we'll test it in that as well. Test. So this one reads 92.5 with an ESR of 4.8 ohms and a V loss of 5.2%. Now I will grab a brand new one and test it as well. The other cap, 94.7 microfarad, 3.3 ohms ESR, and a V loss of 4.4%. So let's get a couple brand new caps once again. So these are 100 microfarads at 10 volts. 100 at 10. I've got a bunch of brand spanking new caps here. I'll just go ahead and shear off 2 of them just like I did for the test. We'll get my little cutters out here. We'll cut those aside. These are the exact ones that I used in this unit. Exact values. No substitutions here. (109.7), 0.16 ohms ESR, and a V loss of 1.1%. Well, in my book, that's at least 4% better than 4%. And for the next one, should read almost identical. These are batched produced capacitors. 109.7, ESR 0.14 ohms, and a V loss of 1.3%. So I'm going to say that we definitely made the right call replacing those 2 100 microfarad caps. Anyhow, that's going to be it. The wrap up on the Definitive Technology SuperCube III. These are, what are they? Cushion caps. 100 at 10s. Oh, and they're only 85 degrees Celsius caps. Come on, people. Oh, man. These are the replacements that I'm using. 105 degree caps. Same value, 100 at 10. And I think these are probably either Panasonic or Nichicon caps. Maybe Kimmit, but Kimmit always puts their name on them. But I know they're much higher quality caps ordered from Mouser.com. Anyhow, that's it. The wrap up. Thank you for watching the bonus material. I really appreciate it. Everyone have a great day. Bye-bye.